centimeters in diameter, but you have a few boulders measuring 1 to 10 meters in diameter. So first thing is that the instructor is using different units to really emphasize the difference. So if you were to draw a histogram, and you don't really need to know about the unit conversions, but let's just say it was in centimeters, you know, one centimeter, 2 centimeters. What they're saying is like most of them are here. And then 1 to 10 meters in diameter, that's 100 centimeters. So way over here to the right, he's saying there's a few over here.
Yeah.
Okay. So the shape here, and I don't remember if you had cats or like cats, but you can think of the long tail of a cat going out to the right. This is right, skewed.
Okay. Yeah.
Because the tail goes to the right.
Yeah.
So
Got
what I
it.
would recommend is drawing a quick distribution, and that will help to
Okay.
answer the question. All right, so
Sounds good.
to do number 2, we're going to look at the answers first before we even read it, just so we know what each of those are. Simple random sample, you're looking for something that says they're equally likely. A
Okay.
convenience sample, they typically use the word that is like convenient or easy, like lack of effort, you could think of that.
Okay.
The stratified is you divide into groups,
Hmm.
some number of groups, and then you choose within those groups randomly. And there are others, like this does not capture them all. You're missing like systematic. I've actually not heard of sedimentary sample.
I
That
think it's
doesn't,
just a
that,
play on
yeah,
words, like
yeah, I
a
think that's
sedimentary rock.
kind of funny, actually. Voluntary means that there's a choice, like you don't have to participate. A lot of the polling done in election season is voluntary, which is why some of the results don't make sense. So now we can go back and read it. You decide to conduct another one here is cluster. I mean, is there other ones, or do you think this is it as far as like what they're gonna?
Those are all the ones we've done in class.
Okay, so you don't even know these other ones then,
Yeah.
but there are others that are sort of common. You wait outside the public library and hand out your questions to anyone who looks like they love rocks. Um, I would say this is a voluntary sample. Could be convenience. I don't
Okay.
really like the wording of it because they love rocks. Do you have the answers to know for sure?
You didn't give us the answers.
Okay.
Yeah,
So if
no.
I would maybe send an email or see if there's a discussion board and ask about this. The reason it's voluntary is because they don't have to decide. Um, they can say whether to say
Hmm.
yes or no, but it is very convenient. You're just going somewhere and you're just handing them. Typically, surveys are voluntary. Typically,
Yeah.
so like if I had to get it down to one answer, I would probably go with C. But convenience is where you're just people are there and you say, all right, let me just ask these people. So
Yeah.
I
When my group and I did it in class, we picked voluntary sample.
okay.
So mhm.
All right. Okay, which of the following statements about the standard deviation, sigma, and mean mu is generally true? Okay. Um, you have to be careful here. Like sometimes they refer to the normal distribution, but
Mhm.
this one just is saying like in general. So in general, standard deviation is positive, or sigma is positive. Okay.
Yeah.
That's generally always true. It is the measure of a spread of a distribution. Okay.
Mhm.
Now the mean can be positive, it can be negative, which you're wondering, well, when would that ever be? But think of just negative temperatures. Uh, the mean is affected by outliers. So if it were written that way, you could put a check there. It is affected by
Yeah.
outliers. Sigma is also um, well, how do we say that? So yeah, it is affected by outliers in general. Um, because they cause the spread of the data to be, let's say this is your little distribution, and then you got one over here. The standard deviation definitely is going to be affected. So if that word not was removed, then it would be there.
Mhm.
Mean and sigma generally don't have any relationship with each other. So none of these other ones appear to be true based on what I'm seeing.
Okay. So it's A and C.
That's my best interpretation of this, but
Okay.
you may want to look at your notes on this sigma thing. Because technically,
I said, yeah, I don't know. I said that
mu
F
and
is
go ahead, sorry, go
true.
ahead.
I said that F is true because the
So the
mean has
data,
to be greater than 0,
so
right?
again, like if I give you the temperatures in Canada, -3, -4, -5.
Oh, got it. Okay. So like the numbers that are, yeah. Okay.
Yeah. The reason I'm still like mu and sigma is that the direct calculations of them have nothing to do with the outliers in your data set. Like you just still calculate them.
Yeah.
It's written oddly. It's like usually it's like which is a better measure of center, mean or median, and it's the median because the mean is affected by outliers, meaning it's not a true measure of center, but the actual calculation isn't. And the way this is written is just kind of odd.
Yeah.
But I guess we'll go with that. So do you think your multiple choice will be this substantial? Um, 8 choices.
I mean, a few of the other questions are like that as well, but it's the select all that apply.
Yeah.
Yeah.
Okay. So quantitative data
Mm-hmm.
is numbers. All right.
Mm-hmm.
Scatter plot is a good choice.
Yeah.
Stem or stem and leaf plot is a good choice.
Mm-hmm.
Or data. Um, the difference between a histogram and a bar graph is important. Typically, histograms are used with numerical data. A
Mm-hmm.
bar graph is generally like pie charts are generally used for categorical data. Categorical data. Pictograph is pictures. It's used for categories again. Line chart, I don't know what that is referring to. Evil plot is not appropriate here.
Yeah. I think line chart is just when there's um points on the graph and you're connecting them. So I said that would be
It is.
numbers too.
It's generally for numbers, yeah. But it's
Yes.
weird that they like the scatter plot makes sense. Line chart is the connection of them. Um,
Mm-hmm.
like you said, the dots get connected. So I would go with those. You also want to read into this, like I just mentioned here. Let's just say it was qualitative data. You'd want to know to choose, A, C, and H in that situation.
Okay.
And that's why I was asking if we thought these were the questions because they almost read like more, like you said, it's a study guide. So maybe the teacher's trying to get you to remember certain things
Mm-hmm.
when you do this. All right. All right. So here we go. Number 5. All right. Number 5 here. Let's go look at the answers. So completely random design. You could probably realize that that means that it's truly random. Did you
Yeah.
guys talk about block designs?
Yeah.
So blocks are typically like groups. Um,
Mm-hmm.
groups groups are usually the experimental and the placebo or control group, not placebo control group. Um, the matched pairs would be like before and after. Could be one person, doesn't necessarily need to be like 2 people. It could be like your left hand and your right hand.
Mm-hmm.
Uh, Block design. So the word that I picked up here when I started reading it is half typically almost always refers to like a block design. The blocks mean groups.
Yeah.
So here your instructor really likes rocks. All the local rock collectors and categorize their primary motivation for rocks. Among each category, you randomly select half of the collectors to receive. Oh, randomly select half. Sorry, maybe that isn't. I gotta be careful here. Um, Among each category, you randomly select half the collectors to receive either 1 centimeter, and you record their reactions. So I'm bothered. It's not completely random.
Mhm.
It's actually like a stratified because you're creating this. You're this group, fame, fortune, friends, beauty, and then you give it the half of the within each group.
Mhm.
So half get it. Um, so uh, I don't think it's completely random. Um, it's like random within the group. So I guess I would still go towards block design on this
That's what I said.
if you're asking. It could be worded slightly better to make that clear.
Yeah. Okay.
All right. Okay, got another problem here. Number 6. All right, number 6 says, which of the following are true? The first one says that really it's saying that all the events in the sample space, the probability of each of those events equals 1. Now this isn't written great. It really should be written slightly different, but I think the interpretation here is that like let's say there's 3 events in the sample space, the probability of all 3 of the events will add up to 1, but usually they say something like summation of the
Yeah.
probability of the events equals 1. So that's where I'm a little like I don't really love it. I think it's could be correct, but like what is true is like the probability of event 1 plus the probability of event 2 plus the probability of event 3 would equal 1.
Yeah. Like if it had the SI underneath it, I don't know. I said it's
Yeah, I don't
correct.
think it's that one. I don't think it's that one, but that's where it's kind of leading. All right, now the probability of A and B is the probability of A plus the probability of B sometimes. So this is sometimes true. Um, it's it's there's a but the true definition of B is typically probability of A and B is the probability of A plus the probability of B, minus the probability of, no, I'm doing it backwards here. So there's this, maybe you guys haven't done this right. Let me do it differently. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So if you solve this for A and B by moving it left and subtracting this over to the right, you can still see it's not correct. Sometimes the
Mhm.
probability of A and B is the probability of A times the probability of B. These are considered the axioms of probability, but I'm going to say probably is not correct so far. All right, so probably
Okay.
not A, probably not B. Let's look at the next grouping here of answers here. So the third one, way it's typically written is it's like the probability of A plus the probability of not A equals 1. So it's like the probability of winning. Let's say winning is 0.58. The probability of losing is 0.42. These always add up to 1. The
Mhm.
question is like,
Yeah.
does this actually does this actually work? And the answer is no, because it's not written right. Um, when you move it to the other side, there should be a subtraction. So it's like C would be correct if probability of not A equals 1 minus the probability of A. That would be correct. So then the
Okay.
only one that appears to be correct is D, because probabilities must be between 0 and 1. They must be.
Got it. Okay. All right. Can we go back to why is A not true?
Uh, it's not written correctly. It probably is true, but it's
Okay,
not
that's
written
why.
like I would have preferred it to say like S1 plus S2 plus S3, or have a little sigma in there to show all of the probabilities. Like, is it correct? Like, and so you probably already know this, but I'm gonna ask you about your teacher. Are they like a really formal math instructor, or are they kind of a not formal?
Not formal.
Yeah,
It's
so that's why
very
they're writing it this way. Yeah.
all over the place.
Yeah, and that's why some of the other questions, because I'm very formal in math. I mean, I don't expect you to, but that's why I'm having trouble here, because this is not the precise definition of it.
Yeah.
And that's okay. We just got to do, so yeah, I said it's not true, but when you're giving your final answer, let's say it is true. That's
Mhm.
where I was also bothered by some of these other ones. Like I would have expected 3 or 4 of these to be correct in this one. So
Yeah.
I think you may want to look at your notes, or at least teacher copied and pasted and meant to like put the not on one of the words. That was sort of bothersome there, but um,
Yeah. I emailed him to see if he has
good.
an answer key, but
Good. Right. You might throw in like, hey, I was looking at rocks over the weekend and I really found them interesting. You might get some response. There's clearly a, interest in rocks here. Again, you go up
Oh my
outside,
gosh.
pick up a random rock and measure
Every,
its.
yeah, every single one of the quizzes are about bears. They're just all bear themed. I don't
Yes,
know. He
bears.
has
Yes. You could
I think
say
he
I
should
was
have
I
been an
was out in the
English
woods.
professor.
Yeah, bear spot, bear watching, and picked up some rocks and okay. All right, you go outside, pick up a rock, measure its size. There's a probability model corresponding to the choice of rock and a random variable corresponding to the size measurement. What is the sample base of the probability model? What is the type of random variable? Okay. Uh, so there's a probability exercise choice of rock. Okay, so it's really like there's 2 questions here.
Yes.
What was it referring to? Choice of rock. I think he miswrote this, because I think it's measure its size. That's the random variable that he's asking about. Although it kind of reads, there's a model corresponding to the choice of rock, which there's actually 2 different answers for this. So let me do it this way first, and then we'll talk about the other one. So the type of random variable is continuous for size.
Okay. Yeah.
Okay, and think of it as like, can you keep breaking it up into like half, half, half? Like is it okay to say like
Mhm.
120.5 and then 120.25 and 120.125 and so on? Like that's what it means for be continuous. You can
Right.
keep breaking it down. Now, if it was choice of rock is, and discrete's not the best label for it, but like think of it as like it's got, we only categorize it, think of categories, okay? But something that discrete is like number of refrigerators. You don't have
Mhm.
half a refrigerator. You can't cut it in half. Um, so the sample space is like the smaller, you can think of it as the smaller group that represents the larger
Yeah.
group.
Okay.
So it's never the universe. Um, the free samples at the grocery store, set of all rocks. So whenever you see the word all that refers to the universe. So that's out. Um, So I guess this part A isn't really referring to the scenario, but the samples they give out at the grocery store are a smaller group, I guess. I don't like any of these answers. It should be like the rocks in the local area that you're picking them up.
Yeah, I
So
know. That's why I
samples,
said the set of all rock because it's a set of
that's
rock.
that's the okay. I see where you're going with that. So I guess that's what he's
I
looking
just
for here. But that like that's if you could choose them all, and you don't
right.
choose them all, you choose a smaller subset. So I guess I see what
Mhm.
he's referring to here. Set of all rocks is the population. This is actually a population. I
Uh-huh.
think the way to interpret is it's like, what are you selecting from? You're selecting from the set of all rocks, but you're not selecting all of them.
Yes. So what's the difference between a set and a sample?
Okay, so a set could be your population. Like let's say you had four rock, like let's just say this was your population, this is all the possible rocks. The sample would be like selecting two of them. You're selecting from the population, but you're only
Okay,
choosing a couple. You're not choosing all. Oops.
got it.
It's like the
All
better
right.
they typically like you're at the University of Utah. It's like let's say you wanted to find out about students perception of family weekend. You don't have the time to ask all the students. So you create a sample.
Yeah.
Your sample would be like people that maybe go to the student union at lunchtime and you talk to people there. And that's your sample.
Okay. But the
But you
set
can't,
is university students
well,
of that,
sets are a way to
right?
organize data. Sets are just a way to, like a set um, could be everything, but it could be like cars. It could be like car one,
Hmm.
car two. Like it doesn't have to be numbers, but the sets are just a collection of things. But if you
Okay.
consider your set like the set could be, all students.
Hmm.
That's okay. But your sample from the set might just be, student one, student 500, student,
Yeah.
899. That's it. Whereas the set is everyone. You can think of as everyone or everything, but the sample is a
Okay.
smaller portion of that.
Okay.
All right. Are you allowed to use a calculator on the test?
Yes.
All right. So number 8 can be done with a calculator or by hand. It's easy to do by hand, but if you want me to try to use a calculator, it's also easy in the calculator. Do you have a preference?
Um, yeah, let's do it on the calculator. See how to,
Yeah.
I don't know how to
All
do
right.
it.
So I'll grab my calculator, but you're gonna put all the data into L1. So that's stat, edit, I believe. You do not have to put it in
Okay.
order, although that could help. So let me get the calculator out.
Okay.
Okay, clear that, edit. All right. 10, 17, 10, 12, 20, and 9. Okay, so make sure you double check that you've entered the data incorrectly. That's where a lot of the mistakes are made. And then you quit
Mhm.
out of that. That calc one variable stats. That calc one variable stats. Yours may come up with a screen. Just accept the default and paste that in.
Okay.
Do you see something like this down there?
Yeah, hold on. Mhm. Okay, so I have my numbers in it, and then how do I get to that, the bars?
Okay, so stat, calc, and then hit one variable stats or one var stats. Yours may come up with another screen, um, but hit enter and then paste and let me know if you see the X bar equals 13.
Yeah.
Okay, so you want to scroll down and now that's your 5-number summary right there. All right, so I'm going to snip that into the other screen. So
Oh,
5-number summary
lovely.
min, so that's part A. Part A is all those numbers right there. To do part B, you can also
Okay.
do it on the calculator. So to do that, you're going to hit the second button and then stat plot, second stat plot. And you should see plot 1 off, unless you've done this in
Mhm.
class. You'll hit enter and then you turn it on. And then the type, you want to go down and choose the type that looks like a box plot. That
Mhm.
you want to choose that first one. The first one will show you outliers. I
Oh,
don't think you have any in this data set. Maybe you do. Um, hit enter to choose it. So let me know if you need a moment to get caught up here.
okay. I got
All
it.
right. So now when you hit graph, depending on what you've graphed, you may or may not see it. Or you might see other
Okay.
stuff. So you may need to go to your y equals and clear out stuff there.
Oh, yeah.
The other thing you
Okay.
can do is reset your memory before you go into a test. That will also help. Now we're going to hit the zoom button, zoom there, right there in the middle at the top. And we're going to choose, you can hit the up arrow. We're going to choose zoom stat or number 9. What that does is it creates a window for the statistic, which is the box plot. Hit enter on zoom stat and you should see a much nicer plot there. So your instructor is looking for certain things when you graph this. So I'm going to snip this into the other window and we'll go back to that. Any questions though on what we did before we proceed?
Oh, that is lovely. It's so cool seeing all the things my calculator can do.
Yeah, you can make some friends in class with your knowledge of calculators, maybe.
It has like all the elements on it too.
Yeah. So
That was so
so
good for chemistry class.
yeah. So your median is 11. That's the middle number. Your Q1 is 10. You want to make sure you label these. Your min is 9. Your Q3 is 17, and then 20
Mhm.
for that. Okay, so make sure you label the axis when you draw it on your there. So
Yeah.
that's part B. And then we can do part C. So part C here, IQR. IQR is Q3 minus Q1. So your Q3 is 17, your Q1 is 10. That is
Uh-huh.
7. And then there's what's called the lower fence and the upper fence. So the upper fence, and these are for outliers, is Q3 plus 1.5 times IQR.
Yeah.
So that's 17 plus 1.5 times 7, which is 27.5. And then the lower fence is Q1 minus 1.5 times IQR. 17 minus 1.5 times 7, which is 9.5. And then you go back to your data set and you look for, are there any numbers outside of this window? There are, which is the 9. The 9 is an outlier. Okay, which means our graph didn't show that. So why didn't it show that? I must have chosen the wrong plot.
Oh, is it a different type of? Let me try the other one.
Yeah, I'm gonna try that one as well because it should have shown that no, it didn't show that. So that's one of the issues with the box plot is it doesn't show the outlier.
Okay,
But
but I know how to, yeah, the
yeah,
1.5.
this is probably sufficient for what your instructor wants.
Yes.
All right, can we move on to number 9 now?
Yeah.
All right, so one thing you might do when you see a histogram is you might actually label the heights of them immediately. That will help with counting. So it says find the
Uh,
number of rock collectors who preferred rock sizes, rocks with size between 1 centimeter and 3 centimeters. You're just adding 15 plus 20, which is 35.
yeah.
Part B is, let me grab part B. What proportion of rock collectors prefer rocks between 1 centimeters and 3 centimeters? So it's 35 out of the, so it's the ones you want over the total. The total is adding them all up. It doesn't tell you the total, so you have to add them all together. Uh, 5 plus 15 plus 20 plus 10 plus 5. All right, so 40, 50, 55 maybe.
Um, yes, 55, 35 over
55.
55.
All right. And if you could reduce if you wanted to, or a decimal's okay, typically.
Mm-hmm.
Part
Yeah, I got
C,
0.64.
you said 0.64.
Yes.
Good, good. All right, what is the probability that a randomly chosen rock collector will prefer rocks with size less than 1 centimeter? So that's out of 5 out of 55 or 1 out of 11. And these could all be turned into multiple choice with the answers.
Okay.
All right, so we're up to
So,
10.
mhm. Yeah.
All right. All right, calculate the mean and standard deviation for the recorded age and number of rocks. So I would put this into L1 and L2. And you said you're allowed to use a calculator, so I think we should go right back to that for this.
Okay.
Does that work?
Yeah.
All right, so I'm gonna go back to the other screen. All right, so you're gonna go back to stat, edit. If you ever want to clear out all the data in the top, you go up to L1 and hit the delete. No, is it delete or clear? I think it's clear.
I just clear.
Clear, clear. Don't do delete. Delete will
Yeah.
remove it. And then you'll have to reset your memory. Um, 10, 30, 50. Okay. So this for the mean, you have to do them separately, but you're gonna go do a stat calc one variable stats for each. And so let's do that. That calc. All right. So the mean is the X bar number.
Okay.
And the issue I have next is what I don't know is whether your instructor wants you to use S or X in that table there. So S is the sample standard deviation, which
Mm-hmm.
is usually the right one. So you might want to send an email asking like, which one should you use? Um, because the sigma is the population standard deviation. You can see they're far enough different that if it were multiple choice, both answers might be there. It just depends on what the instructor wants here. He should say
Okay.
sample or population. Or there should be words in there that say like something like assume that these are all the rock in the area or all the people in the area.
Okay. Um, the
But you want to
variable
do
I have, yeah, is the one, the circle with the little curly on
that's sigma?
it. Yeah,
Okay.
that's what we use.
Okay. All right, so use that. All right, so the same thing for the other one. You may have to change your list. So when you do the one variable stats, you'll have to choose L2 in your list when
Uh-huh.
you do that. On mine, I don't have like it defaults to using L1, so I have to manually change to L2, but that's what you want to see. One
Yeah.
variable stats L2. And so you should see, this set of data there. Any questions on that before we go on to part B?
Nope. Got it.
Okay. So part B is to calculate the correlation. I have to do something real quick to get it on. Uh, uh, where is it? Um, why is this not give me what I want? Sorry, that's the wrong place. Okay. You don't need to do anything I'm doing. This is just me doing something that I do every time for what we're about to
Okay.
do. So ignore what I'm doing. There it is. Okay, so you can go to stat, calc, and then linreg, stat, calc, linreg for part B. Um, and you hit enter. You just accept the defaults, and you should see something like this on there. Let me know if you have something different.
Okay, wait, for the X list and Y list,
L1
what
and
do I put
L2.
in there?
Yeah.
Okay.
I'm gonna go back to the other screen for a moment. Okay, find the correlation R. There's your R right there. Does that match yours?
What's happening? Hold on. Did something wrong.
Let me know if you need me to go back to the
Okay.
calculator.
AX
It's stat,
plus
calc,
Q.
reg,
Yes. Okay.
and yours should by default have the R squared and the R on it.
Mine only has Y, A, and B. It doesn't
So
have
you
R
got the same
squared in
problem I
there.
had. All right, so to do that, you do have to do the thing I just said. It's not that bad. Let me show you. Hit the second catalog, which is
Catalog.
zero.
Love it.
And you go down until you see diagnostic. This is like useless Jeopardy knowledge right here. There it is. You go to diagnostic on, hit enter, and then
Mhm.
enter again. And then you do have to redo the stat calc reg, but it will it will work.
Yay. It did it.
Good. All right, so
Cool.
back to this here. So it says find the equation of the least squares regression line. So part C here is y equals 1.35x minus 5. You'll probably get a multiple choice where it gives you different equations. You have to choose the right one.
Okay.
Part B is to use the least squares regression line. So it does assume that x is in L1 and y is in L2.
Yeah.
So in this case, this is the x value. So it's y equals 1.35 times 30 minus 5. So you grab your calculator and calculate that.
35.5.
Okay, very good. All right. So part E is actually sometimes you need units on this. So the units are number of rocks. I guess there's no units for that, but number of rocks.
Yeah.
All right,
Okay.
interpret the value of R and the slope of the regression line in the previous part. So because the R is positive, 0.97, because R is positive, the relationship is direct variation. So as one variable goes up, so does the other. So as
Oh yeah.
age increases, so does the number of rocks. So they're looking for a sentence that says that.
That it's a positive correlation.
Yes.
We use
Yes.
positive and negative.
So the negative correlation, R, if
Okay.
R is
Yeah.
negative, then as one goes up, the other goes down, or as one goes down, the other
Yes.
goes up. That could also be a
Hmm.
possibility.
Yeah.
M is 1.35. And so what that refers to is that X variable, the age. So it's like uh, as as you get 1 year older, it's always one something. You then say 1.35 more rock expected.
Okay.
So it's a recipe. Like whatever the slope is, that's what you're gonna have more or less of as you get 1 year of the X variable.
Okay. Got it.
All right, so number 11 is the normal distribution problem here. We did a couple of these last time, so if you need some reference for that. So you read the problem here as a mean mu of 5 and a sigma of 2. You want to find the probability that your variables between 4 and 6. So you
Hmm.
calculate two z's. You calculate z1. Z is x minus mu over sigma. 6 minus 5 over 2, which is 0.5. And then Z2 is 4 minus 5 over 2, which is minus 0.5. And so you can then say, okay, I want everything from 0.5, sorry, minus 0.5 to 0.5. We can do this on the calculator. I'll show you that because I showed you the table last time.
Hmm.
So you go to this second distribution. Yeah, I think it's second distribution. And you want to choose
Okay.
normal CDF, second one there. Yours will likely have a nice window. Mine doesn't. So the way it goes is it's the lower value. I think yours says lower, and then yours says upper. If it doesn't, you're going to be not like your calculator very
Hmm.
much. Then it's the mean, then it's the standard deviation. Then you hit paste. You should get something like this when you're all done.
Okay. What do I put for my lower and upper?
Minus 0.5 to 0.5.
Okay.
Did you get something like this?
Yes.
Okay.
Got it.
All right, so really quickly, we're gonna do the last one here. So the smallest 1% means that it's the area in the normal distribution that's over here on the left, where it's 1% or
Mhm.
0.01. So you have to look that value up.
That's the Z thing, right?
Yeah, and so just
The
with
probability.
yes, it's gonna be let me just give you the number here. So it's minus 2.33.
Okay.
So the formula is Z equals X minus mu over sigma. So X equals Z times sigma plus mu. So your Z is minus 2.33. Your standard deviation was 2, and your mean was 5. There is a way to do this in the calculator. Also, it's a little bit harder, but this is the calculation there.
Okay.
And the reason it's 0.1% is because we're doing the smallest. Sometimes they ask about the largest. And so
Mhm.
you have to go to the other side, which would be 2.33. Probably both answers will be there on a multiple choice.
Okay. Cool. And then that's I would put
That's,
that in centimeters,
yeah,
right? Okay.
yes.
All right.
All right, we hit
Well,
the
perfect
goalpost.
timing.
Yeah, we're